Hey everyone, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale Armortek radio-controlled T3485. Since the last video update, a lot of progress has been made to the tank suspension, and the model's swing arms, as well as the majority of the lower hull details, are all completed, all of which we'll be going over in this video. And here we have the components to assemble some parts of the suspension. More specifically, the parts that you see here are to assemble the two front portions of the swing arms that are found on the T34. The way the Armortek kit strews out the parts is the way you see it here on the table. First, you have these four pieces here. These pieces here are going to comprise that of a bracket system, which is going to contain the spring, shock absorber, and swing arm once fully mounted. We have here the outside swing arm. This is the part that actually will eventually connect to the road wheel. We have here the actual springs themselves. Now, these pieces here are all CNC'd aluminum and are nicely machined, which is basically standard for what one would expect to find on an Armortek kit. What's very nice about this is that we have one section here which is threaded. This, of course, is going to be for the axle. And the other side here is a square cutout, and that is going to be for the lock for that of the axle, which will actually be doing the suspension work. For the inside portion, we have these two yoke mechanisms here. These will transfer the rotational type movement from the external swing arm, and this will actually connect to the main spring mechanism, which will give you the suspension resistance. Again, made from CNC'd aluminum. Moving on takes us to some CNC steel parts. These pieces here are going to be used for that of the spring and will actually contain everything together. Moving to another CNC'd type yoke assembly. This is a guide for that of the spring, and again, the machining is very nicely done. The actual axles themselves are made from steel, which makes them very strong, and once assembled, this is going to be a very durable piece. Note, they are pre-drilled for use of pins, which are also kit supplied, that hold everything together. Here we have the wheel axle, which is typical for Armortek's tooling, to have the piece made from a single piece of CNC steel and is threaded to thread into the actual swing arm. We have some brass fittings, which are made from CNC'd stock. We also have here two turned CNC pieces of brass, which are bushings. These are where the axle will enter into the tank from the outside, and it has a nice bearing surface to them, which is again typical for Armortek tanks. Finally, we have two very long M6 fasteners. These are actually going to become the guide rods for the actual springs when the suspension is fully built. Right now, the pieces are going to start going into their refinement, where the tolerances on some of the pieces are very snug, and I'm going to open them up slightly just so the movement is nice and free, which will allow, of course, the suspension to function nice and smooth. In addition to that, many of the components are going to be receiving a coat of primer, and then from there the installation can start progressing. And here goes one of the front wheel spring mounts in its assembled state. The pieces do go together fairly well and are pinned in place with that of a steel pin. Now, on this unassembled version over here, before I assemble it, I want to point out that the tolerances may be a little bit on the tight side in getting the steel axle to fit into the aluminum swing arm. Now, what I like to do is remove just a little bit amount of material on the aluminum arm itself, with a square file in order to open up the tolerances just enough for the piece to fit on with a little bit more ease, as you don't want to just bludgeon it in with a hammer, as that can cause some issues with damaging or marring up either the pin or the softer metal swing arm. And here's the swing arm placed in my vise in order for me to remove just a little bit of material in order to open up the tolerances. For this, I will be utilizing a square file, like I mentioned before. Now, when it comes time for the actual filing, you want to go in a nice, slow, methodical manner, and you want to keep it as parallel or as straight and level as possible, as you don't want to remove too much material, as if that happens, the axle can be mounted on in a canted manner, which can lead to issues. So it is very wise to go very slow and periodically test fit the piece in order to make sure everything is where it should be. And there you go. The piece slides right on with not a whole lot of effort and or coercion needed with that of a hammer. Now, it's also important to point out that you need to have a left and right hand unit, and this is extremely important, as once the pin gets inserted, the piece is not going to be very easily dismantled, so you make sure you get it done right on the first try. Of course, again, this requires the builder to take his time and not rush, as you don't want to make any sort of mistakes like that. Once the axle is mounted to the swing arm, it is then time to pin it in place. Now, I believe the stock Armortek kit supplied you originally with steel pins in order to do this procedure. However, unfortunately, I believe I'm missing the bag of pins required for this installation. Now, rather than contacting Armortek to getting the steel pins, which I'm pretty sure that they will do, as their customer service is very good, rather than doing that, I'm just going to go ahead and make new pins out of some bar stock. The pins will be mounted in place and then smushed in with that of a hammer on either end. This will permanently lock the axle to the swing arm. Now, this exact same procedure I have done on many other Armortek builds in the past, namely that of the German tanks. With the way the torsion bar system is designed, the pinning is a feature that I like to perform to prevent the pieces from unthreading. On this model here, it's basically for the same purpose. To do the pinning, the pin is inserted into the pre-drilled hole, and with some taps of a hammer, I bludgeon the ends so that finally the piece will not come out and be wedged in place. It is at this point of the build in which I can now start mounting on the bushings. Now, like what was showcased earlier, the bushings are CNC brass and are very nicely machined, and just like with a few of the other parts, some hand fitting may be required in order to loosen up the tolerances just enough for the piece to fit on in a nice, precise manner. Now, in order to open up the tolerances, for that I use a Dremel with a rotary drum, and the sanding drum goes at a very slow speed. A few passes in a circular motion, keeping the Dremel at a nice level and steady pace. A few passes with that, and then the piece should have enough tolerances for it to fit in. Obviously, again, this is another portion of the build where you want to be very careful, as you can over sand and again cause for some issues. As for any agents used to hold it in, I'll be utilizing red Loctite for this purpose, as this is also recommended by the instruction sheet. Epoxy may also be used, or even super glue may also be used for this type of application. As for this build, I'll be again using red Loctite. Put a liberal amount on the stem and also on the little recess here that the piece will lock into. Carefully line it up, and with the use of a rubber mallet, a few taps, and the piece should be nice and seated in. This step here will be repeated until all of the bushings are installed. While assembling the block, I've seen one little area where I could improve upon the kit original, and that has to do with the way the piece is assembled. The way the kit is designed, you have this rotating block here, and it gets sandwiched in place by these two brackets. Two M5 by 30 millimeter fasteners are what's used to bolt everything together and keep everything in place. The design is a good design and will work very well. The one place where I saw that could be improved is due to the tolerances of the way everything is machined. When you bolt everything together with the stock configuration, the piece will actually tighten onto the rotating block and may prevent it from fully rotating freely. In order to alleviate this, I went ahead and will be utilizing two small washers to act as spacers. This will free up the tolerances just enough so the piece can be clamped on fully and securely, but the block can still rotate absolutely freely. Now, in addition to the washer, another mod that I made was the replacement of the actual fastener. As you can see, even in the stock configuration, the fasteners don't go ahead and grab into the securing block with a whole lot of threads. Even with the spacer added, even less threads are going to make contact with the block. Now, the main block is fully drilled and tapped very deep into the material, so rather than utilizing the kit fastener, I'll be replacing it with a longer fastener. As you can see, a lot more material is being grabbed by the threads, thus making for a nice, stronger piece. Now, just prior to getting the block fully installed, what I am going to do is I'm going to add a little bit of grease to both sides here of the block, which of course will help lubricate it and keep it spinning with a lot less effort. Quick little smear on either side is more than enough for the lubrication for this component. The last procedure due before the installation of this piece is add some blue thread lock to these two bolts over here. The purpose of using blue as opposed to red is because the blue will keep the fasteners firmly in place and prevent them from getting loose during the tank's operation. However, it is not a permanent bond in case any maintenance whatsoever needs to be done to this component and the fasteners need to be removed. The blue Loctite will give way before the red Loctite will, and will protect the fasteners from possibly getting stripped or worse. Quick little smear on either end. And the piece is now permanently mounted to the bracket, and as you can see, the swing block is free to pivot. This is now ready for installation to the tank. To mount the bracket to the inside portion of the hull, that's facilitated by 4 countersunk screws which are found on the outside portion of the model. Now, these fasteners here can hurt the look of the model, and to take care of this, I'm going to go ahead and delete them with the bodywork. However, before I do that, I want to go ahead and drill out these countersinks slightly deeper so that when it comes time for the bodywork, it's done a lot easier when the fasteners are below the model surface as opposed to being flush to the surface. This does help with the bodywork and it makes it less troublesome in blending everything together. To drill out the pieces deeper, I'll be utilizing this 3/8 of an inch drill bit on this drill, and I'm going to go ahead and drill in probably about a 1/16 of an inch deeper than the way it is right now. This should give me just enough clearance from the model surface with the fastener, but will not enter too deep inside of the plate, which can cause issues as the bracket itself is pre-threaded, but the threads do have a certain point in which they end. You don't want to drill in too deep as they will bottom out inside of the piece, which will lead to some issues and cause some problems in trying to rectify. So drill shallow, just enough so that the piece is just below the surface, and you should be good to go. And here are the fasteners that have been mounted to the model, and they, as you can see, they are below the surface, which again will aid when it comes time to deletion with that of the bodywork. Now for the installation of this component here, this is done utilizing red Loctite, as this piece here is a permanent installation and doesn't need to ever be removed for any sort of maintenance. While installing the suspension components, one important bit of detailing that needs to be added that also serves an important function is that of the bump stops. Now, the bump stops on this model here, again, both serve as a detail element, but are also extremely important, as since the tank is radio controlled, these pieces do have to function. For these components here, the kit supplies you with the following units. They supply you with a bunch of these CNC'd aluminum blocks that are pre-tapped and drilled, and get bolted to the side of the tank. Now, on the bottom portion here, there would be a little self-adhering rubber square, which is actually, they look like the type of things that you would find in office supply stores that you would stick on the bottom of project enclosures or any other item to prevent it from sliding on a table surface. It is a clever design feature in the way Armortek did it. However, even though the pieces do appear to function very well, detail-wise, they are a little bit soft. To improve the detailing on these pieces, normally I would fabricate brand new ones and more likely cast them in resin. However, because this tank is radio controlled, the resin casted units are not going to be viable for this build. So rather than going ahead and creating the pieces in cast resin, I went ahead and opted for creating them in cast metal. Now, the T34 utilizes two types of bump stops. We have here the ones in the front and the ones for the rest of the vehicle. The ones in the front have two rubber bump stops present, and because of which have this more wider and larger receptacle. The rest of the bump stops only need one rubber bump stop themselves, and the receptacle is a lot smaller and stout in comparison. These pieces were heavily studied from the real units that I was able to acquire photographs of. As you can see, the cast texturing is very, very porous and rough on these pieces. However, this is a feature that is deliberately built into these components, as the parts on the real Russian T34 were not exactly known to be of very fine machine quality. The pieces are all solid cast and are all milled to their correct height. And as for the bump stops themselves, rather than utilizing the self-adhering ones that came with the kit, the sets will come with their own flex soft rubbery resin bump stops. These pieces are designed to work with these pieces here and will mount on in this manner. Now, unlike utilizing any adhesives, these will actually be bolted to the component with that of fasteners, which will be added shortly before the installation to the vehicle. We notice that the bump stops themselves have a small little divot and well on the inside. This is so that the head of the fastener is held inside of the component and does not make actual contact with that of the swing arm if or when it ever comes and makes contact with this piece. With the metal alloy that I use, they are more than rugged enough for the application at hand and are definitely far superior for the use of this rather than using resin. Now, in case anyone is wondering, if they do have a static T34 and is definitely running where is not something that's going to be concerned to them, rather than opting for the metal set, I also have a companion set that is made in resin. These pieces here are also added to the ECA product line and are marked and priced considerably less compared to their metal counterparts. As you can see, they also share the rough cast texturing that is found on the metal units, as again, like I said before, this is as per the real vehicle. Now, on this table here, I only have two of these components. However, of course, these will be sold in a set that will give you, the builder, enough components to assemble one complete T34. Even though the pieces are standard resin, the bump stops themselves are the same units found on the metal versions, which will be that of the soft rubber flexible resin, which gives it a nice design element as well as also a detail edge. And here's the model with most of the bump stops now mounted. Now keep in mind, the only bump stop that is not fitted to the model at this point here is the double version, which gets mounted here in the front. The reason for that is that the holes, the mounting holes for the internal brackets that was mentioned earlier, are still going through their final bodywork phase. As soon as the bodywork is concluded, and this is all sanded down flush, the unit will be mounted in its place. As for the other mounts, however, they are fully mounted to the model. They are fastened to the tank with that of the two fasteners, which were originally intended for the kit original pieces. Now, to mount these guys on, I simply marked where the holes go and drilled and tapped these locations. The units are then fastened directly to the tank with the same type of assembly mounts that were mentioned before. The only difference is that the fasteners needed to change. Rather than utilizing the kit fasteners, I went ahead and opted for slightly longer fasteners just for extra strength to hold on and mount on these pieces to the model. All that needs to be added now to the bump stops is that of the sculpted well beads, which will be added shortly after the filming of the scene, and the actual installation of the rubber stop itself. As for the rubber stop, these will be added after the tank lower hull is pre-painted with that of its base coat. Reason for that, quite simply put, is that the pieces being naturally black, I don't want to get them covered up with any of the overspray and paint. With the bump stops out of the way, I can now go ahead and proceed with the mounting and the installation of the remainder of the internal suspension components. The T34 from Armortek has the suspension laid out in the following format with the following pieces of equipment. They are as follows. We have here a CNC'd aluminum spring housing block. We have a CNC'd aluminum pivoting block. CNC'd brass threaded fittings. A brass CNC nut. And a CNC steel housing. In addition to these pieces, we also have here the actual coil spring and a very long Allen head fastener. Now on the Armortek kit, the way the system gets assembled is as follows. We have here a spring locking block like I mentioned before, and we have here a pivoting block. This unit here is pivotal in that it holds the springs assembly once fully assembled. It gets mounted into this unit here, which then gets mounted to the side of the tank and sandwiches everything together. This unit here will pivot inside this location, which will of course be needed in order for the spring suspension to work properly. Now, like what is frequently mentioned on these Armortek builds, the tolerances on the pieces are very finely done. However, the tolerances may be, in my opinion, slightly too tight in order for the pieces to operate in a efficient manner. This is present for the swinging block, where it makes contact with not just the retention block, but also with that of the hull. These four units over here have had their adjustments made, and so that they fit inside of the units with a lot more precision. These two units here, namely these four units I have here on the table, are still stock with the Armortek, and as you can see, are a little tight with the actual installation, and pivoting is a little bit more restricted. Now, of course, after the tank is driven after a while, these will eventually break in on their own. However, on the builds, especially at this point here, I like to go ahead and loosen up the tolerances, which will aid with the final assembly procedure. Now, to do the hand fitting, this can be done in one of two ways. First way could either be done by hand or with a drill press, in which you take the drill bit, you put it in the chuck, and you simply move the piece around, removing just a slight amount of material, which will open up the tolerances. This is doable, however, this will lead to some oblong shape of the hull. It's not going to be anything detrimental that will ruin the suspension, but it's just something that I choose not to use. Rather than doing that route, I'm actually going to use the lathe, and I'm going to take these swinging blocks here, put them in the lathe, and remove a very finite amount of material off of each of these spindles. With the material removed, this is going to make the pieces fit in a lot more of a precise manner, and as you can see, this piece here is nice and loose and pivots with absolute ease. Like I said, to do the procedure, I'm going to be utilizing the lathe. Going to be taking the unit, putting it in the chuck, make sure it's nice and straight on with the chuck jaws. Now I'm going to simply remove the material with that of the tool, and I'm only going to remove a very small amount. Keep in mind the piece does fit out of the box, but you just need to remove just a small amount of material in order to free up those tolerances where the pieces can pivot with a lot more ease. Now, it's important not to over-remove the material required, as this can lead to issues. will now do the same for the opposite side. Then we'll test fit it to the piece. And to test fit the newly machined piece, there we go. I will now conduct the same procedure to the remainder of the blocks. After that, I can then go into the modifications that need to be made to the block in order so I can mount it to the model. Moving our way to the inside portion of the tank, it is now time to get the main spring housing block modified in order for it to be mounted to the vehicle. Here we have on the side of the hull these pre-drilled out holes. These holes here are the opposite receptacle for that of the rotating block that I just showcased in the last scene. Here you can see how the piece will go ahead and sandwich everything together. Now, on the stock Armortek kit, this piece here is designed to be bolted on permanently with that of 3 very long and large fasteners. This system does work and works very well. However, one issue that I can personally see is that when it comes time for any sort of maintenance, or if there's never an issue with the spring housing, with the stock Armortek system, you're not going to be able to remove the unit. Specifically on the way I do these builds, in which the external fastener holes will be deleted after the piece gets mounted, and you're not going to be able to take them off. Rather than going with that approach, I'm going to modify the piece in that the fasteners are going to be bolted to the hull, and then this unit here will simply slide directly over and be secured with that of external fasteners. This is much different compared to the stock Armortek unit in that the holes that are in the tank are not threaded, and the rods, or I should say the fasteners, just slip on in. With their system, if you need to remove the unit, you can, but the fastener will want to slip out of the other side, and if there's body work on it, it's going to be very problematic and can lead to some very ugly issues that you're going to have to deal with that of sanding down and possibly repainting and doing some more body work. Definitely less than ideal. In order to do the modification, the first alteration I need to have been made was that of the fastener locations found on the side of the hull. Here we have the hull side, and this here is the top of the sponson. Each one of these blocks gets secured in 3 locations, one on the side and the other 2 towards the top. The original kit utilized that of countersunk screws, which would have been mounted in these locations here. The countersunks are a frequent design feature found on these Armortek kits, and the depth of the holes that were drilled into the hull is also standard and one that's typically found on the majority of the Armortek kits on the market. Now, in order to do this modification, I needed to go ahead and bore out these holes deeper compared to the stock offerings. The reason for that was the change of the fastener type. Here is one of the fasteners which I will be utilizing for this modification. If you notice, it is fully threaded, and this will come to be important as I go and describe the work that goes on the inside. Because of this fastener, I needed the holes to be bored out deeper compared to the original units. Now, this was done by hand with a hand drill and a drill bit that was the same diameter of the original Armortek holes that were drilled in. However, I went ahead and removed more material, which allows for a sunken appearance, which is perfect for me to thoroughly delete this section when the time comes without the bodywork, leaving for a seamless appearance. Now, because of the thickness of the side armor plate, this procedure is viable, as the plate is thick enough for me to bore further into it, but not to the point where I compromise the strength of the metal. Now, this is a risky procedure in that if you don't have a lot of experience with working with something like this, you can easily over-drill into the hull, which is obviously less than ideal. Now, on the inside of the hull, you can see how the modification is going to work. The fastener protrudes from the inside. Now, is at this point here, I'm going to take a fastener and I'm going to thread it all the way till it's tight against the hull, preventing this piece from backing out and keeping it on in a nice, strong manner. Once this is done, these fasteners are not going to go anywhere and are permanently affixed to the tank, which is why it allows me to do the bodywork on the opposite side, and I don't have to worry about the bodywork cracking off if the fastener was left loose, as per the Armortek design. Now, because of the fastener that will be located here, I'm going to have to remove a little bit of material on this location over here and on each of the locations where the fasteners are present. This is to make clearance for that of the nut, which will be attached to the fastener in this locale. Once that is done, I could simply then just slide the unit directly into place, and then add lock washers and another nut on the end, and this will sandwich the spring housing to the hull in a very secure manner, but in a manner that's also removable if the need be ever arises. In addition to removing the material in this location, I also need to remove the material that makes contact with the hull in these two locations here. These two fasteners here were that of the bump stops, which were showcased earlier, and like I said, I had to change the length of the fasteners compared to the stock originals, and rather than using the countersinks, I just used standard hex bolts. Because of this, they protrude slightly from the tank surface, and to accommodate this, I will mill a slight amount of material away in, again, the appropriate location so that it allows the spring housing to mount to the hull in a totally flush manner.